Now we solved this example, and I'm going to introduce you another formula to calculate velocity in uniform channel flow. In the previous examples, we used Chezy formula, and we had this relationship between velocity and Chezy coefficient and geometrical characteristics of river. And we said that Manning and other scientists provided this formula to make simplicity in order to calculation of C, Manning coefficient, and we saw that as we discussed with your friend, when n increases, roughness increases, C decreases, and when the C decreases, velocity decreases, and consequently, when velocity decreases, discharge will be decreased. Therefore, Manning roughness is always against the velocity and discharge. So Manning, who provided this formula based on experimental works, he gathered lots of information from natural rivers and calculated hydraulic radius and actually calculated measured velocity. Then he had these parameters, he had the measured velocity, and he find C based on those experiments, and he finally showed that there is such a relationship between N and C. And what is the N? We already talked, it is Manning roughness, and he provided several values for different type of canals that he had in his experiments or collected from experiments of other scientists. Anyway, if we replace this value, this equation with C here, what will we have? We will have Manning equation. It is called Manning equation or Manning formula, which is based on Chezy formula. So we have velocity equals to r to the power of 1/6 over n times to the square root of r times s0. You have 1 r to the power of 1/6 outside of the radical sign, and we have r to the power of r to the power of half here. Okay, we can say, okay, r to the power of half and bring it outside of the radical. Therefore, we will have only square root of s0, and if you multiply r to the power of half with r to the power of 1/6, it gives you r to the power of 2/3. And from here, we also have 1 over n outside of the square root sign. So we have velocity equals to 1 over n r to the power of 2/3 times s to the power of half or square root of s. This is called Manning formula, and we can use it to calculate velocity, or let's say average velocity in uniform flow condition. This is more popular than Chezy formula because we are more comfortable with the estimation of n in practice. Therefore, by multiplying area to the velocity, you can have another version of Manning formula, which is used to calculate discharge. Actually, this one is nothing than multiplication of velocity by area. So here you see that again, both formulas are dependent on n. N is a function of vegetation, channel irregularities, obstructions, and shape and size of channel. You remember about shape, we talked about the sinuosity, and so other kind of roughnesses, obstacles in front of the flow. Increasing n means decreasing velocity. and this is, as I told, very popular in the calculation of uniform flow in practice. So one important thing is the original form of the velocity or discharge when you are using Manning formula. Actually, if this formula is given in SI unit, you already saw in the Manning roughness table that n is unitless. N is unitless. Okay. Look, let's look at velocity. This is more simple than this version. We have a velocity. What is the unit of velocity? Meter per second, yes? In SI system, standard system, meter per second. We have here S, slope, dimensionless, yes? And we have R to the power of 2/3. R is from the unit of length, yes, R, hydraulic radius, meter, for example. The unit is meter, meter to the power of 2/3, and here is the meter to the meter over second or meter per second. So you see that both sides are not from the same dimension. If you assume that 1 and n is dimensionless, we know that n is dimensionless, but here 1 actually is not dimensionless. This coefficient has a dimension which makes two sides of this equation dimensionally correct. So this is the one when we have R in terms of meter and V in terms of meter per second, or generally speaking, when the calculations are based on are in the SI system. However, if you use for the American system, foot per second for velocity or cube foot per second for discharge, therefore, from the beginning, we know that n is dimensionless, s is dimensionless. Therefore, the value of 1 should be correct, should be adjusted. Actually, the 1 should be adjusted. This coefficient should be adjusted to make both sides dimensionally correct. And in that system, the coefficient is not 1, is 1.48, as you see here. But as in the beginning, I said that we always use SI unit in this book, in this course. Therefore, our formula is simpler than this one, and we use the coefficient of 1 over n instead of 1.48. So, calculation of uniform flow. So far, we talked about two formulas, Chezy formula and Manning formula. And we saw that both Manning is based on Chezy, and Chezy is based on net or force balance. So there are two type of problems in hydraulics dealing with uniform flow. The first time is determination of discharge for given depths. We already solved one or two examples using Chezy formula, but we can solve the same kind of problems using Manning also. The second type is determination of depths given the discharge. And in the following slides, we will evaluate these two types of questions and to see how we can calculate or how we can solve any of these type of questions. This is the first example, which says the normal depth of flow in a trapezoidal concrete line channel is 2 meters. From the first line, I simply understand that the flow is uniform. Yes, the normal depth. Okay, so flow is uniform. I can choose either Chesney or Manning formula to do calculations. The normal depths, cross-sectional information given, trapezoid, concrete line, and depths also given, normal depths. The channel has a base width of 5 meters and sides of 1 per 2, 1 vertical, 2 horizontal. Okay, so based on this side slope of the cross section and bed, I can calculate again area, wetted perimeter, hydraulic radius. Manning n is given. The question therefore says that use Manning formula or even Chesney, but when I have Manning, I can easily use Manning roughness. I can go with Manning formula. Bed slope is given. Bed slope is given 0.001. Determine the discharge and mean velocity. The question says that, okay, determine discharge. You can use, for example, this formula, then come back here, or at first you can use this formula, which is mean velocity, and then calculate discharge. Anyway, this question is which kind of the problems that we saw here? Any idea?
First one. Right?
The first one, yes. Because we have depths, given depths, yes, normal depths given. And the question asks us determine discharge or velocity. So let's see how we can solve this kind of problems. My suggestion to you, when you solve a problem in hydraulics engineering and you see a question without any figure, first draw your cross section based on the given information. Trapezoidal bed given, y0 given, channel side slope is given. The other given information is you see S0 and N. I just draw this figure, cross section, and wrote all the given information here. So I know N, I know S0, and I'm looking for what? Looking for velocity. And I know that Manning equation can be used. Manning equation is this one. Yes, this is a form of Manning equation. I need to calculate R0 because the other parameters already given. Very simple question, yes, very simple. And the first type of these questions, problems in uniform is really simple. What I should do, I only calculate wetted parameter. I calculate cross-sectional area of this trapezoid, wetted parameter, like this. These sides plus the base, short base of this trapezoid equals to this value, and hydraulic radius equals to 1.29. You remember I told hydraulic radius is always less than the depth of the or maximum depth of the channel in trapezoidal sections. And for velocity, I can replace this R with this value, then put the other information, and you see average velocity is 2.5. Multiplying by area, already you can calculate discharge by multiplying A times velocity, which equals to 45 cubic meter per second. So the first kind of the question are so easy, and you can only what we can do, only we make to make a problem more difficult. I can give you more complicated cross-section shape, but this is not the matter in the hydraulics. This is only complexity in terms of mathematics, in terms of calculation of the area or wetted parameters. The problem from hydraulic perspective is really easy. So this is another example, and in which the question said if the discharge in the channel given in the last example is 30 cube meter per second, find the normal depths. Now You see that normal depth is not given, but discharge is given. Okay, and the question is from the second type of the problems, and this type of the problems is a bit difficult, a bit more difficult than the first type. You see here I have a discharge, but I don't know what is the depth of the flow in this trapezoidal section. I know that it is concrete line, therefore n equals to 0.015. The slope from the up to down in the length of the channel is given, and I know that I should use Manning roughness to calculate y, or to calculate normal depths y or y0. Look at here, I can write, I can calculate actually cross-sectional area and weighted parameter. Both are the function of y, but I don't know why. Therefore, A is unknown, still P is unknown. But I can, I don't need their exact values at the beginning. Okay, I only need hydraulic radius in which I should divide A over P, this or this. So the discharge is the given formula is this, you know, we have this version of Manning roughness, and instead of R, I can write A over P. You know, let's come back here. This is my main formula. What is the R? A over P, yes. A is a function of y, P is a function of y. Therefore, I can remove R with writing A over P. Let's see here. Therefore, this equation is in that shape. The another version, instead of R, I wrote A over P, and I have another A here. And if you multiply those, it gives you this formula. Look, A is a function of y, and P is a function of y. Therefore, I have only one unknown, because already Q is given. Q already given, this left side is given, right side is one unknown. And if you simplify both sides, you will have such equation. And now this is one equation, and you have only one unknown. Maybe you can calculate it with your calculator, or you can calculate it easily by trial and error method. How trial and error method means you have this formula, and you see that I've started with, just a moment, sorry. I've started with what? I've started with the value of 1. I assume that depth is 1. Okay, and then calculated right hand side. I said y should be 1. I calculated right hand side, RHS means right hand side, and I saw that right hand side, this side gives me 5.7. So 1 is not my answer. Let's increase it. I increased it half meter and recalculate the right hand side. It gives me 12.5, and I'm so close to 14, but I'm not still 14.23. What should I do? I should increase, but not significant change. A bit increasing the height, and I did it for 1.6. I found this value. Never, I'm closer, but not 14. I increased 10 centimeter again. I see that now I'm a bit far from the right hand and left hand side, so I should decrease again. I decreased 5 centimeter for 1.65. I calculated right hand side equal to 14.65, and you see that it is so close to the 14.23. Therefore, This is one way, trial and error. It is called trial and error method to find the correct answer. Therefore, the normal depth would be something around 1.65 for the previous question. So here there is another example. Determine the type of problem given below. Okay, can you determine it to me? Look, a trapezoidal channel has Manning's n given, bed slope given, made in half hexagon, maximum efficiency. Okay, for what lengths of L, will the channel carry 7.5 meter per square of water in its full capacity? Which kind? This is first kind or second kind?
Second kind problem.
Second kind, yes, because you see that this charge is given and H is not given. Here, instead of H, we have L. The question asks us L, but you know that if you have this angle, H is calculate easily. Or first you can calculate H, then calculate L. Let's see the solution. You see that again I have to calculate area and weighted parameter both in terms of either H, either Y, or here in terms of L. Therefore, my hydraulic radius is a function of L. I have this charge and I have this formula, and we already are familiar. I have the right hand side of this formula by replacing area, replacing r to the power of 2/3, n already given, look, n already given, and square root of S0. And it should be 7.5 from the question. Now, the same procedure, trial and error procedure for different values of all. At first, simplify it, make it simpler. You see, the function is just this. And you can easily calculate L from here by your calculator or trial and error method. When you have your L at hand, you can calculate the normal depth also, but the question already asks you to find L. You see, anyway, both kind of problems are easy. The second one is a bit needs more mathematics. And yep, this is all for today.